Now, how to apply this formula? See, I'll make a diagram for denser to rarer, rare to denser refraction from a lens. Okay, let's take a biconvex lens today. What is a biconvex lens? Biconvex is just a name for confusion. Basically, the lens which is already known by the name convex lens is also called as biconvex lens. This is a biconvex lens or convex lens, and this is a biconcave lens or concave lens. Also, have you heard of concavo-convex lens? See, I'll tell you there are three types of differentiations: plano, convexo, and concavo. I am not going to write here, I'll rather write here. Concavo. Okay. Plano convex and plano concave. The difference between different namings and different type of shapes is simple. First word belongs to the first surface and second word belongs to the second surface. That means the first surface has to be plane and the second surface is to be convex. So this is a plano convex. Then plano concave would be first surface plane and second has to be concave. So this is plano convex, sorry, concave. So convexo plane would be there and convexo concave is also a possibility. So now you guys know the trick. First word belongs to the first surface, convexo. Second word belongs to the second surface, that is plane, and your lens will be formed. So these are basically various types of lens. You can always do this diagrammatic thing by knowing the name. Similarly, for concavo plane and concavo convex, you can always find out the different type of diagrams. Right now we are going to do the lens maker's formula. For that, I will draw a biconvex or a convex lens. What is equiconvex? Convex lens have two different radii of curvature. That is, if they R1 and R2 is equal, then it would be called equiconvex lens, and otherwise it will be a biconvex lens. Okay, so this is the lens, this is the principal axis. Okay, now let's imagine that our object is here. Okay, this is the UO and this is my incident ray. What is to be done next? From refraction from surface 1, there will be some sort of normal like this. I am drawing the normal with the dotted line. Okay, and due to the refraction from surface 1, the ray must travel, instead of going straight, it will bend towards the normal in this direction. So the ray has bent in this direction, right? What if there is no second surface? In absence of the second surface, this ray would have gone straight and met the principal axis here, and the object's image would have formed here. But right now, due to the second surface, there will be second refraction and the actual image. I am also drawing the normal for this surface. Let us say this is the normal for the second surface, the red one. For the second surface, due to second refraction, this time the ray is traveling from denser to rarer medium again. So instead of going straight, the ray is going to bend away from the normal, like this away. Okay, so ray has met the principal axis here. So this is the final image which we have derived from this ray diagram. Do we also know that there are always two different set of rays which actually combine together to give us the final image? So which is the second ray here? It is along the principal axis. Okay, so where these two rays are meeting, you are actually getting the image formation. Now there are two surfaces, so how do you write this derivation? Hope this much space is okay for me. So start writing for refraction from surface 1, in bracket do mention that is which refraction is this, rarer to denser or denser to rarer. That is from rarer to denser medium. Which formula are you guys going to use? I am writing both the formulas here so that you can see what are the changes we are inculcating. Mu2 over V minus mu1 over U is equal to mu2 minus mu1 over R, and secondly mu1 upon v minus mu2 upon u is equal to minus of mu2 minus mu1 over r, right? See the changes in this thing. For refraction from surface 1, that is rare to denser, I am going to use this formula, which is mu2 over v. Where is my v? Object distance is u from the central line of the lens. This is image distance, and this is the image distance for the image which was forming or formed due to the first surface, not the second. This is the final image though, but due to the first, this was the image which was to be formed. So in case I am taking the first surface only, I have to consider that image which was getting formed by the first surface. So mu2 upon, I will be taking v dash this time, because the image due to first surface is at this point, which is at this distance, minus mu1 upon u, right, is equal to mu2 minus mu1 over r1, because there is a possibility that both the surface has different radii of curvature, so that is why r1. Then for refraction from surface 2, that is denser to rarer, for this surface, this equation gets transformed into this, right? So I am writing mu1 upon v minus mu2 upon, what is the object distance? U. What is the object distance for the second surface? See, what is an object from which the ray is actually coming? For this surface, ray was coming from this point. That means, see the direction of ray, this is object, that is okay. But for second surface, this is the ray, okay? So where is this ray coming from? Extend this ray along, you won't get any position on the principal axis from which this ray is actually coming. But this ray is also meeting the principal axis imaginarily at this point. That means the image which is formed from the first surface is acting as an object for the second surface, which is still imaginary. Again, the image for the first surface is acting as an imaginary object for the second surface. So this itself is the object. So what will I be taking this u? U is this thing here, this u. This u will be the v dash, is equal to minus of mu2 minus mu1 over, let it be r2. Equation 1, equation 2. Add both these equations. When you add these two equations, what will we get? This part, I have to add these two equations. So this part and this part will cancel out. This being positive, this being negative in sign, this will cancel out. You are left with what? Mu1 upon v, adding, right? Mu upon v minus mu upon u. This is what we are left with. On adding, I am getting mu1 over v minus mu1 over u is equal to mu2 minus mu1 can be taken common out from both these right hand side, right? So I am taking mu2 minus mu1 common out, and I will be left with what? 1 upon r1 here minus 1 upon r2. This is what we got after adding. Take mu1 common, 1 upon v minus 1 upon u is equal to mu2 minus mu1, 1 upon r1 minus 1 upon r2, right? What else? I am bringing this mu1 down here. So I can remove the brackets also now. So this is the term which we are left with. What is this, by the way, from the lens formula? From the lens formula, this is equal to 1 upon f. So instead of this, guys, I don't want to rub this out right now. So take this whole thing. I am writing this whole thing here. This is 1 upon f, which is equal to mu2 minus mu upon mu1. This thing, I can also write it like this. Watch. Right? the denominator can be taken with both the terms. So this is basically 1. So you are left with mu2 minus mu1, mu2 upon mu1 minus 1, mu2 upon mu1 minus 1 into 1 upon r1 minus 1 upon r2. This is what? This is basically the refractive index of the lens, this term mu2 upon mu1. So this is your final answer, mu minus 1, 1 upon r1 minus 1 upon r2, right? This is your final answer. I have just one question for you guys. If it is an equiconvex lens, that is 1 upon r1, basically if r1 and r2 are equal, so 1 upon r1 will be equal to 1 upon r2 numerically. So this term is going to cancel out. It's going to give me 0. So what is the flaw in this question, like this formula? Is there something wrong? Well, it's not wrong. It's absolutely right. See, even if r1 and r2 are equal, this is now I can rub, right? You guys can actually pause the video right now. You can write it all and see this. If lens is like this, which side is the r1? r1 belongs to this surface. If you complete its sphere, you will get r1 on this side, right, which is positive. If you complete this sphere, you will get r2 here on the negative side, and r2 being negative, you will write minus of, suppose r2 and r1 both are 20 centimeter, it would be 1 upon 20 minus 1 upon minus 20. So this term will ultimately get positive. So this is the lens maker's formula.